Assalamu alaikum dear students, hope you are fine by the grace of Almighty Allah. Welcome to NIBS Home School. I am Sabreena Haque, Assistant Teacher of Science, National Level English Version School, Teship. Dear students, today I am going to take a science class for class 9 student on the based on subject chemistry, and today we will start chapter 8. Today we will discuss the part 1 of this chapter. So let us move forward to today's topic. Dear students, the name of the chapter is Chemistry and Energy. Dear students, only this chapter is related to your subject name, and we know through the chemical reaction we get the energy, and this energy and related to the chemistry is the topic of the chapter 8, and this is one of the most important chapter of your chemistry subject. And when we burn wood, it makes fire. Similarly, when petrol, diesel, etc. are burned and the engine of automobile, the car is run, and this is to say these have energy. This energy is called chemical energy. Look, this picture is a burning candle, and we know the material of the candle is wax, and when we lit the candle, that with the help of this fire we get the light energy, and through which chemical reaction the wax or hydrocarbon react with oxygen which is stored in the atmosphere, produce carbon dioxide, water vapor. Along with this we also get light energy and heat energy. That means we get the energy through the chemical reaction of hydrocarbon and oxygen, and this is the topic of the chapter. Now come to the chemical energy. The first lesson of this chemical energy is source of chemical energy. Matter has molecules and atoms remain connected to another atom because of attraction energy, that means bond. Similarly, a molecule remains bonded with another molecules due to another kind of attraction, intermolecular attraction. These energies are called chemical energy. Now come to the bond energy. In a chemical bond, the energy by which an atom remains joined with another atom is called bond energy. Now come to intermolecular energy. In covalent compound, the energy that keeps the molecules combined with each other is called the intermolecular energy. Like water is a covalent compound, intermolecular energy combine the molecules of surroundings water molecule of water. On the other hand, the ionic compound sodium chloride are 6 chlorine ions surrounded by a sodium ion. Look, this is a sodium chloride, and when it makes the crystal 1, 2, 3, 4, 5, 6 chlorine atom or ions surrounded one sodium ion. Similarly, 1 chlorine surrounded by 6 sodium ion, and that's why their intermolecular attraction or energy is so high. That's why they just bond so strongly, and that's why in the normal temperature, room temperature, the ionic compound stays solid. The attraction energy between ions of an ionic compound is stronger than the intermolecular energy present between covalent molecules, and that is why melting and boiling point of ionic compound is greater than those of covalent substances, and we already learned this in our chapter 2. Their melting point and boiling point of ionic compound is too high because of their bond, and that's why they remain solid in the room temperature. On the other hand, the ionic compound remains solid in the room temperature. On the other hand, covalent compound usually remains liquid or gaseous state in the room temperature. What is room temperature? Naturally, which temperature is stay in our room outside, that is known as room temperature. Now intermolecular energy or in a covalent compound consisting of atom of two elements, that is hydrogen and chlorine. When the covalent compound make with different types of elements, that is stronger than the covalent bond made with same element. That means hydrogen chlorine is different atom. There they make the covalent bond, and here hydrogen make like this way, hydrogen and hydrogen make the covalent bond to make the hydrogen molecule, but this covalent bond is weak than this covalent bond. And we know the covalent compound are bonded with weak van der Waals attraction force, and but here because this is different types of elements, that's why their bond is some strong than that of the same elements atoms bond, covalent bond. Now come to the transformation of energy in chemical reaction. Dear students, just when we start the chapter, that time I have told then when we get the light and heat from the wax, that time the wax react with oxygen and produce carbon dioxide, water vapor, and the heat and light energy, and energy, heat or light energy, and only energy. That means from where we get the energy? From the bond we get the energy. By breaking the bond we get that energy. That now we are going how the transformation of energy in the chemical reaction happens. Each substances contains some energy. Usually in chemical reaction the energy of reactant is necessary to make the reaction happens. To some chemical reaction result in generation of energy. That means the energy is transformed into chemical reaction. Energy requires making a reaction happens, or resultant energy from a reaction may be different from like heat energy, light energy, electricity, sound energy. Like in a dry cell, from the chemical energy, when we switch on the torchlight by using the dry cell, we get the light energy and some of heat energy. That means here chemical energy turns into light energy and heat energy, and also from the burning candle we get light energy and heat energy. There also chemical energy transform into light and heat energy. Now unit of measurement of energy, this portion are known to us because the calorie or kilocalorie was the unit of unit to measure the energy, and the definition of calorie, the heat applies to raise the temperature of 1 gram water 1 degree Celsius is called calorie, and 1 kilocalorie is 1000 calorie, and kilocalorie is expressed by CAL. Now presently the international standard unit of all kind of energy is joule. That means SI unit of energy is joule, and there is the 1 kilojoule is equal to 1000 joule, and we know there is the definition. 1 joule is the work done by a force of 1 Newton acting through 1 meter displacement. This is the definition of joule. You have to memorize it, and 1 kilojoule is equal to 1000 joule. Dear student, there is the relationship between calorie and joule. 1 calorie is equal to 4.18 joule, and 1 joule is equal to 0.24 calorie. These things you have to remember to solve the mathematical problem of this chapter. Now come to next portion, classification of chemical reaction according to the change of heat, that we already learned in our previous chapter. That is, there according to heat production or absorption, there is two kinds of chemical reaction. One is exothermic, another is endothermic. What is exothermic? From which chemical reaction heat is produced, that means reaction place become hot, and that is exothermic. Another one is endothermic, through which reaction heat is absorbed, and that is endothermic. And in the endothermic reaction, the reaction place become cold. In an exothermic reaction, the value of del H is negative. This is a rememberable thing that you have to remember. The del H value in exothermic reaction is negative, and in endothermic reaction the del H value is positive. Any substances has a specific energy in a specific temperature. The energy is called internal energy. That is the definition of internal energy. Dear students, we can find by value of del H by using this formula. Here del H is equal to total internal energy of the product. That means that is said by E2 minus total internal energy of reaction. Reactant, it will be reactant, not reaction, that will be reactant. The total internal energy of the reactant, it is E1. That means del H is equal to E2 minus E1. In the exothermic reaction, the total internal energy of reaction, that means E1 is greater than total internal energy of products, that means E2. Therefore, the value of del H is E2 minus E1 becomes negative because the reactant energy is more than product energy, and the just opposite happened in the endothermic reaction. There the product energy is more than reactant energy. That's why the value of del H there will be positive. Now come to the exothermic reaction examples. The chemical reaction in which heat is evolved are called exothermic reaction, and reaction place become hot, I have told. And come to the example, that is the methane or natural gas. Methane, when we burn the methane or natural gas in presence of oxygen, it produces carbon dioxide, water, and it also produces 890 kilojoule per mole. Here, dear students, 1 mole methane react with 2 mole oxygen, produce 1 mole carbon dioxide and 2 mole of water and 890 kilojoule per mole heat energy. And here the value of this, because this energy is produced here, that's why the value of del H is minus 890. That means this portion is E1, this portion is E2. Del H is equal to E2 minus E1. This means here the energy of reactant is more than energy of products. That's why we get minus 890 kilojoule per mole energy. And from where we get the energy? By breaking the bond of them. By breaking the bond of them. If you think the methane has 4 bonds with hydrogen, and oxygen is these types of bond, oxygen double bond. When we break the bond, that time we get the energy to produce carbon oxygen bond and hydrogen oxygen bond. That's why there we get 890 kilojoule per mole energy or heat energy. Again, when calcium oxide and water react, if you observe when the labor done the whitewash of a building, that time they mix the water with the calcium oxide, that means lime. When lime and water mixed, that water become boiling, and because they produce calcium hydroxide and heat energy. That's why we see the water and calcium oxide, when mixed with each other, the water become boiling because of this heat energy. Because here the bond energy is more than this bond energy. Calcium hydroxide bond energy is more than calcium oxide and water, that means oxygen hydrogen bond that has the more energy than that of calcium hydroxide bond energy. from there we get this much energy. That means 63.95 kilojoule per mole energy we get from this portion, and this is why the Rayleigh's value is negative, because it is heat production, heat is generated through the exothermic reaction. We know when the E1 is greater than energy than the E2, that time the Rayleigh's value will be always negative. Now come to the endothermic reaction. The chemical reaction in which heat absorbed are called endothermic reaction. This is the definition of endothermic reaction, dear students. And we know in the endothermic reaction the value of Rayleigh's will be positive. Look, this is the picture of preparation of edible lime from the oyster, and look, this is the fire. We have to apply the heat to make the lime from the oyster. That means the main component of the oyster shell is 98% is calcium carbonate. When we give the heat to the calcium carbonate, it makes calcium oxide, that is edible lime, and also carbon dioxide. Carbon dioxide mixed with the atmospheric air, and we get only the calcium oxide from that. This is the reaction of that calcium carbonate, plus we have to apply 176.8 kilojoule per mole heat energy, and we will get calcium oxide and carbon dioxide, and here carbon dioxide mixed with the atmospheric air, and here the bond energy is less than these two bond energy. That's why the value of Rayleigh's is positive. In your book that there is printing mistake, that is written negative, dear student, it will be positive. That means Rayleigh's is equal to plus 176.8 kilojoule per mole. Now come to the calculation of heat change in the chemical reaction using the bond energy. Dear student, we can easily count the bond by using the bond energy, the value of Rayleigh's. The value of Rayleigh's in a chemical reaction is determined in two ways. One we have just seen in the above discussion, and in the other the determined in using the bond energy deduce the total bond energy of the product and the total bond energy of the reactant. The result in the both ways is the same. That means if we use the Rayleigh's is equal to E2 minus E1, and if we use the next rules, next formula, that result will be same. The energy required to break the bond of atoms of a compound and separate them is called the bond energy. This is the definition of bond energy. We get also these things in our previous part. Again, the energy required to form the bond of them is form bond of atom of a compound and combine them is called the bond energy. During chemical reaction, breaking of bond of the reactant and formation of new bond of product take place. Energy is needed to break the bond and the energy is released in the bond formation. And in any reaction, if there is total bond energy of reactant is B1 and the total bond energy of product is B2, then the heat change in the reaction is Rayleigh's is equal to B1 minus B2. That means total energy required in breaking the old bond, that is B1, and total energy released in the formation of new bond, that is about the product, that is B2. B1 minus B2 is equal to del H. Now come to the in exothermic reaction, the value of B1 is lesser than B2, and so the value of del H is negative, while the endothermic reaction the value of B1 is greater than B2, so the del H is positive. Now this is the bond energy that is given in your book that you have to learn. Most of the time when you get the mathematical problem, they give the bond energy value, but you have to learn it because for the MCQ and knowledge based question, and sometimes they can't give, that's why you have to apply from your knowledge. Then the table says that oxygen bond is a 498 kilojoule per mole, that we understand 498 kilojoule heat is required to break an oxygen bond. On the other hand, the formation of oxygen bond evolve 498 kilojoule heat. Here they give an example. Then their problems: determine the heat change in the reaction methane plus chlorine, and product is chloroethane plus chlorine. Here bond of Ch8 is equal to 414 kilojoule per mole. Bond energy carbon chlorine is equal to 244 kilojoule per mole, and bond energy of hydrogen chlorine is equal to 431 kilojoule per mole. Here in the book they give in a short description of the problem solving. They give the reaction: 1 mole carbon hydrogen bond, this is the methane, and this is the chlorine, and it dear students, look, only one bond breaks, and here CH, only one CH bond breaks, and only one chlorine bond breaks. On the other hand, one carbon chlorine bond create, and hydrogen chlorine bond create, and we have to calculate. That means total bond energy of the reactant breaks down. Only one CH bond breakdown and one chlorine bond breakdown. That's why we have to calculate 414 plus 244 kilojoule. That means 658 kilojoule energy is applied on reactant to break the bond. And total bond energy evolves in production of the bond formation. That means carbon chlorine bond and hydrogen chlorine bond. In carbon chlorine bond we evolve the energy 326, and hydrogen chlorine bond evolve energy is 431 kilojoule. That means 757 kilojoule energy, and heat change in the reaction del is 658 minus 757 kilojoule, that means minus 99 kilojoule. Since the del S is negative here, that is exothermic reaction. This reaction evolves 99 kilojoule per mole heat. Dear students, this is another problem that we will do now. This is propane. Propane react with oxygen and it produces 3 moles of carbon dioxide and 4 moles of water, and here they give the del S value is negative, and del S is minus 2280 kilojoule energy, and we have to calculate the bond energy of carbon oxygen. Now come to the solution. Here because this is a chemical equation, we will give the equal sign in between. First we can count here 3 carbon, here also 3 carbon, here hydrogen is 8, and here hydrogen 4 to the 8, and here oxygen is 10, here 3 to the 6, and here 4, that means 10. That means this is a chemical equation. We can write directly with the help of equal to sign. 3 plus 4 OH. Now count the bond energy. Here, 8, 1, 2, 3, 4, 5, 6, 7, 8. 8 CH bond. This 8 is the number of mole. This 8 is the number of the 8 mole of CH bond plus 5 mole of oxygen bond is equal to 1, 2. That means 3 to the 6 moles of carbon oxygen bond plus here 1 and 2. 2 4 the 8 mole of oxygen hydrogen bond. And from the table we can put the value of CH bond's value is 414 plus oxygen bond's value is oxygen double bond's value is 498. 6 carbon oxygen bond plus 8 oxygen hydrogen bond is 464. Here 6 CO bond is equal to the total value of this one is 5802 minus 3712. But in your question they are given the del H value, so we can write, we know this portion is equal to del H is equal to del H, so we can write here minus 2280, and if we take this portion here that will be positive. 6 carbon oxygen is equal to 5802 minus 3712 plus 2280, or total if we calculate you will get 4370, then it will be divided by this 6, or carbon oxygen double bond value is 728.33 kilojoule per mole. Dear student, if you observe in the table that is written here. Now come to your homework. This is your homework. The ethanol react with oxygen and produce carbon dioxide and hydrogen. This is your homework number 9. And you have to calculate the value of del H from the reaction. Dear students, this is a chemical reaction. You have to first equal. You have to make it chemical equation, then you can collect the del H value. Without making the equal of both sides of chemical reaction, you can't find out the del H value. First you have to make the equal of both sides, then you can find out the del H value. Dear student, it will be water. Sorry for that. That means ethanol react with oxygen, produce carbon dioxide and water. We have to find out the del H value of this reaction. By following the previous math, you can easily find out this del H value, and you have to submit Saturday from 9 AM to 3 PM this SW. Dear students, this chapter is very important for you. Read the chapter very carefully and do the SW. Thank you. Allah Hafiz.